So today, we are going to be talking again about the integumentary system. Specifically, we're going to talk about skin color and the variations that we see naturally in the human population. Okay. So our focus questions are what factors affect skin color and how does the skin heal. So today, we're really only talking about that first question. The next lecture, we'll be talking about how the skin heals. So there is a video that's about the science of skin color. I think it's pretty cool. But let me know if you actually hold on. Let me get this to actually work. While the video is playing, go ahead and take notes on things you think are important. We should have space in the...
This look like it's cold.
No, this is not like March.
They're just there. All right.
George is
When ultraviolet sunlight hits our skin, it affects each of us a little differently. Depending on skin color, it'll take only minutes of exposure to turn one person beetroot pink, while another requires hours to experience the slightest change. So what's to account for that difference? And how did our skin come to take on so many different hues to begin with? Whatever the color, our skin tells an epic tale of human intrepidness and adaptability, revealing its variance to be a function of biology. It all centers around melanin, the pigment that gives skin and hair its color. This ingredient comes from skin cells called melanocytes and takes two basic forms. There's eumelanin, which gives rise to a range of brown skin tones as well as black, brown, and blonde hair. And pheomelanin, which causes the reddish browns of freckles and red hair. But humans weren't always like this. Our varying skin tones were formed by an evolutionary process driven by the sun. It began some 50,000 years ago when our ancestors migrated north from Africa and into Europe and Asia.
I'll just pause it there so that you can
We need to go back a little bit.
Like all the way to the beginning. Slow down.
Like when they mentioned
Put it at 0.1 speed.
The types of melanin?
Yeah, I don't know what the
That was too quick.
I think it's
Slow it down.
slow it down.
that is very...
Oh, the erasing.
I don't think it's going to let me.
Why did you put this up?
June, so it's right there.
And hair its color. This ingredient comes from skin cells called melanocytes and takes two basic...
We talked about melanocytes the other day. Yeah, so melanocytes are the cells that produce this pigment called melanin. Okay, and you don't have to worry about the two different forms. It just pretty much means that there's two variants of the pigment which give you the different skin tones as well as hair color differences that we see. And so depending on which form you have dictates part of your skin color as well as your hair color.
There's eumelanin, which gives rise to a range of brown skin tones as well as black, brown, and blonde hair. And pheomelanin, which causes the reddish browns of freckles and red hair. But humans weren't always like this. Our varying skin tones were formed by an evolutionary process driven by the sun. It began some 50,000 years ago when our ancestors migrated north from Africa and into Europe and Asia.
It was formed by what? Revolution?
Evolutionary.
Evolutionary
evolutionary process. So I mean, it pretty much means over time there were changes that occurred, random mutations, and then this force, like the force that's driving this, was the sun. So the sun is really the biggest factor of why we see different skin tones.
These ancient humans lived between the equator and the Tropic of Capricorn, a region saturated by the sun's UV-carrying rays. When skin is exposed to UV for long periods of time, the UV light damages the DNA within our cells, and skin starts to burn. If that damage is severe enough, the cell's mutations can lead to melanoma, a deadly cancer that forms in the skin's melanocytes. Sunscreen and
So UV rays, like UV radiation, right? Radiation causes mutations. If those mutations end up hitting, like if those rays end up hitting melanocytes, you get mutations, and then that can develop into a cancer depending on what mutations are there.
they didn't exist 50,000 years ago. So how did our ancestors cope with this onslaught of UV? The key to survival lay in their own personal sunscreen, manufactured beneath the skin, melanin. The type and amount of melanin in your skin determines whether you'll be more or less protected from the sun. This comes down to the skin's response as sunlight strikes it. When it's exposed to UV light, that triggers special light-sensitive receptors called rhodopsin, which stimulate the production of melanin to shield cells from damage. For light-skinned people, the extra melanin darkens their skin and produces a tan. Over the course of generations, humans living at the sun-saturated latitudes in Africa adapted to have a higher melanin production threshold and more eumelanin, giving skin a darker tone. This built-in...
Okay.
So technically, the more melanin you have, kind of like you're safer from the sun, basically.
Yeah. So because the sun and the UV rays has been, if you think about like 50,000 years ago, it's saying, right? All of humans were right around the equator. They were in the Tropic of Cancer. They're in a very highly concentrated UV ray area. Okay. So having darker skin in that area was a really great mutation because it meant that they weren't going to be burned from the sun. They were going to have more protection and a less likely chance of like developing a cancer because of those mutations.
Wait.
So when humans ended up migrating to different locations, there's different amount of UV rays that occur depending on where you are. And that'll go into it too. So it's because of like darker skin and more melanin actually helped protect humans.
So more melanin equals darker skin.
Yeah, so the more like melanin is a pigment, right? So the more pigment you have, the darker you are. The less you have, the lighter you are. Yeah.
helped protect them from melanoma, likely making them evolutionarily fitter and capable of passing this useful trait on to new generations. But soon, some of our sun-adapted ancestors migrated northward out of the tropical zone, spreading far and wide across the Earth. The further north they traveled, the less